So it's now live. So number 32, really special guest, Argenis, welcome to the Hangouts. Finally, we made it. So a few words for you, sir. How are you first? How are you?
Good morning, sir. It's so great to be here with you today. And we have been talking about doing this for a really long time. I think
2 months at
wow,
least.
yeah,
Yes. Yes, two
it's
months at
hard.
least. So it's now true. We are live, and then we'll have a
Yeah,
recording.
yeah. Let me pinch myself. Yes, it's true. I'm here.
Yeah. So before we start the topic, you know that you have to introduce yourself. You are a speaker.
So my name is Argenis Fernandez. I am a SQL Server MVP since last year. I am also a Microsoft Certified Master in SQL Server 2008.
Okay.
That is now a defunct certification, so rest in peace. Um, I am a frequent speaker at many events, including the past summit, TechEd, formerly known as TechEd, SQL Bits, and a whole bunch of other events like Dev Connections and things like that. So
Yes.
I've spoken at a whole bunch of places. I am rather active in the community. I've spoken at something like 20 SQL Saturdays or something like that. And I've been doing this for a really long time.
Yeah, by the way, that surprises me. The fact that you are an MVP for just 1 year, that's really surprising.
Right. So I used to work for Microsoft, and when you work at Microsoft, you can't be an MVP.
Oh
And
yeah.
so after you leave Microsoft, there's something like a waiting period, which is kind of loosey-goosey in terms of exactly how that works.
Okay.
Typically, a year after you're eligible, and then somebody went ahead and nominated me, and I got the award. So I'm very happy for that.
Yeah. Oh yeah, absolutely. So we are going to talk a bit more about you, where people can find more about you at the end. Now let's dive into one of the most interesting subjects in the SQL Server world. We decided to talk about storage.
Yeah. Storage is your best friend and your nemesis at the same time.
Yes. Why did we decide to talk about storage? Can you please remind me?
I don't know, man. I think we were looking for stuff to talk about, and I've been working with storage for a while now, so I guess
Yeah.
storage is as good a topic as any, right?
Yeah, absolutely.
Actually,
But
you know what I found out there? 99.9% of the instances of SQL Server that I work with
yeah.
are storage bound. So they have no issues with memory, they have no issues with CPU, the issue is storage.
Yeah, so probably that's why this makes it an interesting topic, right?
Yep.
Yeah, okay, so why is SQL Server, why is it, first of all, let's introduce this. Why is it crucial for SQL Server to have a good storage? At least in your opinion.
So there's two reasons, right? The first reason is that the data is persistent on disk, right? And so as transactions are being performed on the server, they're being written to the transaction log, right?
Yep.
And so the transaction log becomes your first bottleneck right there, right? The transaction log is actually storage. So the data that you write to the transaction log is actually flagged as write through. So the write actually needs to hit the transaction log before anything else happens.
Yes.
So imagine in a server that's extremely busy, your transaction log is going to be the first thing that needs to be like properly well tuned, right? So
otherwise, it will slow down everything.
Right, exactly.
And then?
So typically what you will want is on your transaction log to provide some performance of less than 5 milliseconds, because otherwise you'll start seeing all sorts of weird things happen in your server, right?
5 milliseconds. 5 milliseconds. Let's do the details. Yes, that's for write, right?
That's for a write to the transaction log. You would expect at the most 5 milliseconds. If you do any higher than that, your server is going to be super slow.
Okay. So here it comes. First suggestion: always monitor for your. Hopefully, you have all of the transaction logs or the single transaction log on a separate disk. So that disk should be running at 5 milliseconds.
Wait. Yes. So yes, I agree that generally speaking, you will want to have your transaction log on a separate drive.
Yep.
However, with the advent of new storage technologies,
who said Fusion IO?
Well, not just Fusion IO though. I mean, Fusion IO is a great technology, of course, but with the new storage arrays that I'm seeing out there, we actually use one as SurveyMonkey. The old flash arrays, we are not worrying about transaction logs on a separate drive anymore. We actually have one flat LUN for everything.
Yeah. Yeah, absolutely. That was
And
something
so,
that, yeah.
and so we get to that, right? But so
Yep.
that was the first part, persisting the data in the transaction log. And then the
Okay.
second part is as the asynchronous process of taking the data from the transaction log to the data files happens, right? Checkpoint and lazy writer and all of that.
Yep.
Then you will want to retrieve that data somehow, right? So if it's not in memory anymore because it has been flushed out, and now you execute a query, and that query demands to return some data from your disk. Well, now you're not performing a logical I/O, you're performing a physical I/O, and then your disk is now potentially, again, a
Yeah.
bottleneck. So as you see, data in, data out, right? Then
Yep.
the biggest thing is memory. So this is why I recommend everybody just max out your memory as much as possible.
Yeah. And speaking of this, we're talking about storage. We talk about the speed of the storage. So can you recommend what are the, at least in your opinion, from what you have seen, what are the values that we have to see in terms of latency? Because many people, when they hear those numbers for first time and when they compare those to their systems, they're like, that's interesting. That's interesting. So what are your numbers?
It's obviously going to depend, right? Like you could have an extremely busy system running on pretty crappy storage, but you have a ton of memory, so you don't do a lot of physical I/O.
Okay.
And so you could have a super fast storage system, and you could have very little memory, and then you're performing a lot of storage, and so
Yep.
it's a problem as well. So there's a balance there, right?
Yep.
Obviously, the more RAM you get on your server, the better off you are. But generally speaking, if you're getting reads that are higher than, I would say, between 10 and 20 milliseconds, then that's a little bit high, right?
Okay.
I have, of course, seen systems that are way higher than that, right?
Oh.
I actually worked with one system in particular, now comes to mind. It was running on a really old array, well, old for standards, right? So this is, I think it was a 2009 array or something. That array was, the latency on it was 1.6 seconds for each write.
Yeah.
That was unbearable. Like I could have never thought that I would see such a system, and that thing just didn't perform at all, right? We have all sorts of issues with that.
Yeah.
So generally speaking, you will want to remain under 100 milliseconds. Or when you're already hitting 100 milliseconds, things are going to be slow. Okay, so you want to be in the 10 to 20 milliseconds range, maybe. Anything less than that is great, right? Anything over that, things are finicky. It depends on your system, depends on your workload.
And we talk about reads now.
Right. So well, that's what I'm saying. I'm saying in general, reads and writes should be in the 10 to 20 millisecond range. For the transaction log in particular, you will want to be faster than that, right?
Yeah. So do you remember the last time that you saw that fancy error log message which says the I/O operation took more than 15 seconds to complete?
Oh yes, I'm very familiar with that one. So, obviously on that particular system that I mentioned to you, right? You know how it tells you had this many instances of operations that took longer than 15 seconds?
Yep.
That's only triggered when you actually have I/O that's over 15 seconds, but that doesn't mean that you haven't had any I/O under 15 seconds. More than likely, most of your I/O is going to be under 15 seconds. Obviously, that's what it says.
Yeah.
But you don't know if you were running always at 13 seconds and everything was super slow, and you didn't realize that you were running so slow until you were getting that message on the error log. This is what you need to run your perfmon or your monitoring tools and make sure that you're looking at the latency on disk at all times.
Yeah, I remember just one of the most nasty things that I have seen was a humongous problem with a storage array coming from HP, a Neva storage, and we had the problem with the firmware of one of the controllers. So every single transaction was actually going through that controller and not using the 4 of them that we actually had. So at one point we had, and I trust me, I have seen this on a graphic. I saw a 46-second latency to the drops.
Holy crap, man.
So,
you win.
Yeah. And that was at one point at 3 a.m. when the backups were firing up. At that point, you just see more than 100 servers like crushing. So that's impressive stuff. I mean,
I I have a similar story from a place that I used to work for. The storage was
Microsoft?
no.
No. Okay.
So yeah, no, Microsoft was actually fairly decent in terms of storage, right? Depends on which team you were working for, right? Of course, Microsoft has like hundreds and hundreds of different
Yeah.
departments and teams, right?
Yep, yeah. I can
They
imagine.
have hundreds of different SANs that are for different purposes and stuff. But for this particular company that I used to work for many years ago,
Yep.
we were backing up all of our. We have something like 650 SQL servers in production, so it was a huge environment, right?
Okay, yeah.
And a bunch of those servers were actually hooked up to the SAN via iSCSI.
Oh.
So we needed to retrieve the data from the data files via iSCSI, right, into the server, so we could back them up right back to that same SAN, right?
Yep.
Via iSCSI as well.
Okay.
And all the servers were backing up at the same time. And all of the servers, there was this device called the Cisco MDX.
Okay.
Basically do the conversion between iSCSI and fiber. So it will be iSCSI and a whole bunch of ports on your switch, right? One port hooking up or a series of ports hooking up to this MDX device.
Yep.
And a series of fiber connections to the SAN. Well, you had hundreds of SQL servers coming in and only so many fibers going out to the SAN.
Yeah.
That thing was the single biggest bottleneck on our entire environment. And it would take hours and hours and hours for backups to complete. The latency will go way above 200 milliseconds there. Sometimes it will reach 300 milliseconds. It was extremely high.
Yeah.
And the only way to get rid of that was to buy more Cisco MDX devices or fan out more on the SAN side. Things were just ugly, man. It was, I mean, we were reading and writing to the same SAN, a bunch of servers all at the same time. It was just bad.
Perfect. So on the topic of storage, many people read recommendations in terms of SQL Server and write levels. What is your recommendation on write levels?
So RAID, right?
RAID, yeah.
RAID, who cares? Generally speaking, you will want to go with RAID 10, right? That's what's going to give you the best performance, not necessarily the best bang for your buck. But again, things are changing, and things are changing fast.
Okay.
And like I told you before, we're running this all-flash array where you no longer worry about RAID levels. You don't worry about RAID groups. You don't worry about LUNs much. You don't worry about a lot of things. So things are changing so much in that arena that you are basically changing a lot of the assumptions that you needed to make before you actually set up your storage.
Yeah.
And I'll tell you, for us, it's been actually shocking the fact that we don't have to worry about these things anymore. We're getting magnificent performance. Look, I will send you after we're done. So maybe I don't know if you're gonna edit this video or not. If you can put some additional resources on this, I will send you a screenshot of our production array.
Yep.
And you'll be amazed to see every single I/O is completed under a millisecond.
Wow.
99.9% of our I/O is completed under a millisecond.
What's that storage array?
Yeah, it's a flash array from Pure Storage.
Oh, it's not violent memory because I have seen those.
It's not violent, right? So there's many players on that.
Yeah, absolutely.
There's violent. There's Solid Fire. There's TJAL. There's Nutanix. Even EMC and the other players like NetApp and stuff, established ones, are coming out with their own flash arrays because flash is changing everything.
Oh yeah.
For us, it's been dramatic, right? We used to run on a Hitachi SAN that was giving us maybe tops 800 meg per second, 900 meg per second.
Yeah.
With this new Pure Array storage, we can hit 3.5 gig a second, and it's
3.5 gigs per second.
Yeah, gigabytes.
Okay, that's fast. Yeah, that's a lot. Yeah,
it's a lot. I mean, we can do things that we can never do before, right? It would take us forever. So, for example, we're backing up our entire database. It's a 12 terabyte database. So taking a full backup in 2 hours. That's ridiculously fast. Yeah. So yeah, the fact that you're doing I/O so fast changes the way that you do business, right? Because you were essentially limited by that, and now we're saying, okay, so now those heavy queries that we couldn't run before because the storage was nuts, now we can do them, and we actually don't have to worry about a lot of things. So even TempDB we're sitting on that same box, right? But our workload is heavy, but it's very OLTP, and so 10 dB is hardly utilized, and so we can get away with a bunch of things, right? Right now we're not using our CSI, so it's different, but we are eventually enabling our CSI.
Okay, but in general, if a company, if an organization, if the people from the community who are going to watch this cannot afford your storage, what write levels do you recommend for new systems? And if they cannot use 10,
right?
How should they approach the problem?
It depends, right? For example, you maybe cannot afford a flash array, but SSDs are very affordable nowadays, and most people are actually afraid of replacing their existing hard drives with SSDs because they don't know if they're going to be supported or not. I tell you, the majority of the servers will accept some sort of SSD one way or another, right? You don't have to necessarily buy what the vendor would try to sell you. Typically, the vendor would try to tell you, "Oh, a regular SSD will never work on this server," and it's not true. You can actually use regular SSDs on most servers out there. You just have to do maybe some testing and see if things will work. We have Dell servers that are running consumer SSDs, right? And we have an array of consumer SSDs.
Really? Interesting.
Yeah, like a 720 XT server that has you can fit something like 24 disks on that thing. We bought all consumer SSDs on that, and we created a RAID 5.
Oh, okay.
RAID 5 for SSD works just fine.
Yeah. No issue. And you are happy. And if you are not on a flash storage, then what? Then what's your recommendations?
And so it will depend, right? What your budget is and what your storage demands will be.
In general, just throw the general recommendations. Let's call them this way. RAID 5, RAID 1.
Whenever you can go RAID 10, that's the best bet, right? Yeah, you can go wrong with it. But it's going to be expensive, right? And so sometimes you can get away with maybe a couple of disks on RAID 1, God forbid. But it depends, right? If you don't have any money, you're short on budget, and you got to come up with a solution. Yeah, it really depends, right? So there's many counters that you have to take into consideration, right? So number one is the amount of IOPS that you're going to do, right? Yeah. What kind of bandwidth are you going to need? So what kind of throughput are you going to need from those disks when you perform something like a data warehouse query, for example, right? Because typically a data warehouse query will cost a lot of I/O, a lot more than an OLTP system, right?
Yeah.
And the other thing that you have to consider is the latency. So are you okay with high latency but a lot of throughput, for example? Or maybe you are doing OLTP and you don't want that much throughput, but you want low latency. And so it depends on how your storage can be configured, right? Sometimes you can tune certain knobs to make sure that you go for a better performance for LTP workloads versus a better performance for a data warehouse / OLAP workload, right?
Yep. Yeah, absolutely. So
it really depends. I mean, general recommendation, flat out, will be if
RAID 10.
Go for RAID 10. Go for RAID 10 and go for as fast disks as possible, right? Magnetic, you have up to 15K.
Yeah.
Try to get not so large disks, right? Typically the smaller disks will be faster than the other ones, and sometimes you have to go do tricks like short stroking. Nowadays, that's not so common anymore, but it used to be really back in the day that you could short stroke a disk, so that
what does that mean? I haven't heard this terminology. What's that?
So when you have a platter that's spinning all the time, and you have the head that's moving a lot, right? The head is moving like this, right?
Yeah.
When you have as you go into the outer rims of the disk, the reads get slower.
Yep.
So if you remain within the inner the inner rings of the disk, then your reads will be extremely fast.
Yep.
And then what a trick is to short stroke the disk and just format the disk so you only use the inner part of the disk and not the outer part of the disk. Does that make sense?
Yeah, it makes sense, but how is that possible?
Well, you just format. So each individual disk will have to be short stroked so that you can only use that, right? Like formatted to only use that part, like the inner part of the disk. And then you create an array. You create an array of all these disks, right? And this is an old trick, right? Most people are not using this nowadays.
Who is going to do that? Is that the storage admin?
You'd be surprised, actually. A bunch of people did this in the past.
I haven't heard about this, but it's really clever if you think about it. Yeah.
Yeah. So this is actually an old trick, man. Because imagine, I mean, you had this old disks, and you really couldn't get better performance out of
Yeah.
them.
Yeah, exactly. But
And so
is that something that the DBAs do, or is that accomplished with some storage tool that you can
you're
download?
getting
Or
into the other conversation of whether a DBA should know about storage or not. And in my opinion, any good DBA should know about storage, and any good DBA should know about system administration, and any good DBA
yes,
should know about SANs and all these things, right? So typically speaking, you will not hear anybody that knows about short stroking, because that's something that was very famous maybe 15 years ago, maybe 18 years ago. It's not so common nowadays. But
okay.
yet, if you're short on budget and you can only get away with magnetic hard rust, what I call spinning rust, um, you can do tricks like that to
That's
get better performance out
really
of your
interesting.
disks.
I'll definitely research that. I don't know whether or not it's the time to use it because, as you said, it's just we're in 2015. But I would just research that topic just
It's
out
fun.
out of curiosity. Yeah, that's
It's an edge trick. I mean, I remember some people will go nuts and just short stroke their drives on their laptop, right? Because you would get better performance on their laptops, by the way.
okay. That's too bad.
That's
That's too
right.
extreme. Yeah, that's too
Well, to
extreme.
be honest with you, here's what I think, right? In the next 2 to 3 years, there will be a turning point where people will no longer consider magnetic as the best option, or budget-wise, right? Like price, with the higher return on investment will come from flash, basically. So
Yes.
I really think that the old arrays and the old way of thinking about storage is just going away. Is that like people when they think about VMs and things like that, they are they understand that any VM server can handle a regular workload. It used to be the case that people didn't think that VMs would be a good idea for SQL servers. I think that VMs are just fine for pretty much every single workload out there. There are very specific workloads, like very, very, very special cases where VMs don't make sense. But for the most part, VMs are fine, right? The same thing is happening with storage and SSDs, right? And Flash. Flash is changing everything. And it's becoming increasingly affordable. I mean, a Fusion IO card, for example, now owned by SanDisk, it's cheap, relatively speaking, right? I mean, the benefits that you get from having such a card on your server are amazing, right?
Yeah, it's incredible. Yeah, I have seen this in production. It's like a game changer, complete game changer. Everything on just one LAN and just throw everything in there.
And that's just one technology that's changing everything, right? With the advent of SMB 3.0 and Windows storage spaces and direct memory access (RDMA) on the NICs, that's also changing the way that we do storage dramatically, right? So that's actually another thing that I see is kind of disrupting the way that we did SANs before, right? Because you can now do your own SAN on your Windows Server on your Windows Server box.
And Microsoft pushing really
good performance from that, right? So you might not want to buy a direct attached storage anymore. Instead, buy a server, throw Windows Server 2012 R2 on it, RDMA NICs, and decent storage, and you built your own SAN.
Yeah. And Microsoft seemed to be pushing really hard on this technology. At least in my opinion, they're like really pushing on this thing.
Right. And I'm pretty sure that all that stuff is what's powering Azure behind the scenes, right?
Oh, absolutely.
We just don't know exactly how it's built. It's
absolutely. That's absolutely. I'm 100% sure that that's the case.
And so they have to figure out how to do things at massive scale on their own data centers, and some of that technology eventually trickles down to Windows Server, right?
Yeah.
Or Windows Server, the boxed version of Windows Server, I should say.
Of course. But so we are talking about SSDs. What if we are planning to see a world full of flash storage? What are the problems that we should be ready for? What should we know about flash storage, or is it just like throw it there and it will work?
So the classic problem with SSD is it's sort of the garbage collection mechanisms that SSD do, right? So you could be having great performance, and all of a sudden your performance drops for just a little bit, and then it comes right back up.
Yep.
It's sort of like watching .NET performing garbage collection while it's running, right? Like everything is going great, and then all of a sudden you have a little bit, and then everything goes back up. It's kind of the same thing, right? With the typical SSD will perform that way. The technology is changing a lot. The controllers are changing a lot. So not only the controllers inside the SSD drives themselves, the controllers that know about arrays of flash
Yep.
know how to handle this situation, right? And I'll tell you, the storage vendors are getting really creative in terms of, what kind of tricks can we use to make sure that the SSD perform better, right? And the particular, again, I'm going to use the array that I know the most about, which is the one that we have at SurveyMonkey right now.
Yep.
Pure Storage. They perform inline deduplication and compression of the data, and there's nothing you can do about turning that off, which is kind of shocking, right? Because you're like, what? My data is getting deduped and compressed. Like my database files are getting deduped and compressed, and
is that on the fly, or is it on a specific schedule?
And so that's the other thing, right? If the controller cannot keep up with the amount of data that you're writing to it, it cannot perform inline deduplication, then what it will do is that it will write the blocks on compressed, and then it'll go back and revisit those with an asynchronous process, and say, okay, those blocks over there have not been deduped and compressed. I need to go check them out. And so this is all happening behind the scenes in the array, right?
Yeah. So that's why you were saying, because what's that?
No, so the other thing that you can do is imagine now that you have deduplication and compression of your data, you can have multiple copies of your database on the same array that are only taking basically one, a single. That's one block that can mirror multiple versions of the same database.
That's just
imagine the scenarios that this opens, right? For example, on one of our arrays, we have a lock-shift version of our database, right?
Yep.
That we have for the event of oops. So if somebody drops a table in production, go back to that lock shift version of the database and grab that table quickly and put it back in production, right? That has never happened, and we have, crossing fingers. We are very careful about these things, but we also have to be prepared for the eventuality that might happen. And so in this same array, I have a lock shift version of the database.
Yep.
And that's the same array that I restore my full backups to. Right?
Yep.
And then I run consistency checks on that one array.
Yep.
It's on a different data center, so it's completely separated from production. But if you think about it, the logship version of the database and the full backup that I just took from the database are basically the same data. Not a lot is changing, right? On a 12 terabyte database where the data doesn't change a lot, there's a lot of commonalities between those two databases, or those two sets of disk blocks, right?
Yep.
The array is going to figure that out. Like at first, you will see that the space on the array increases once I complete the restore. But as you let the asynchronous process take over and dedupe and compress, only one copy of the database is what's really kept.
Yeah.
And that copy is actually compressed, so it's even further down, right?
Yeah. Yeah, it's crazy how intelligent those systems are becoming. It's just insane.
I am getting compression ratios of 4.5 to 1. Which is amazing, right? 4.5 to 1, right? So I'm still performing reads faster than I could have ever done on any magnetic array, and this thing is mind blowing. Yeah. I'm telling you, this is basically going to change the way that we think about storage, because now it's no longer a bottleneck. When your storage is no longer a bottleneck, everything changes, right? Like you can perform backups faster. Run DBCC, check DB faster. Your queries run faster. Your maintenance runs faster. Everything is faster, and happy DBAs come from that. Yes.
Yeah. So can we end up with one thing that you said really well? Can we end up with something like a recommendation that in the upcoming years, in the next 2 or 3 years, people like us, people who are DBAs or database professionals should learn at least the basics of storage, at least the basics of Windows administration, system administration in general, and stuff like this? Because you said you used terms like deduplication, you used a lot of flash, a lot of technology, which is going on behind the scenes for us. Obviously, a lot of this is changing on a day-to-day basis. I mean, it's crazy how quickly these things are changing.
Technology changes very fast, right? Like 8 years ago, we didn't have iPhones, right?
Oh yeah. Oh yeah.
I remember how things were at the beginning of the cell phone era, and you were carrying these bricks around, right? Right now, you're carrying full-on computers that are about this size, right?
Yeah.
Same thing is changing on the storage side, right?
Yeah, absolutely.
You used to buy racks and racks and racks of trays of storage, and now things are reducing,
Yes,
and everything's changing, right?
it's crazy,
So
and yeah,
I
that's
firmly believe that in every enterprise, in every environment, you should have somebody who understands infrastructure, somebody who understands storage, somebody who understands Windows administration, and just don't think that you can get away with buying a cheap server with cheap storage, because that's not going to give you the best bang for your buck, right? Um,
yeah.
you're going to run into issues later if you don't size things appropriately, and you're going to end up spending more money than you
Yes,
originally
it
scheduled to
will
spend.
cost you more at the long in the long term. Yeah,
In the long
indeed.
run, going cheap never pays, I tell you.
Oh yes, never. I mean, never ever. Absolutely.
Especially when it comes to SQL Server, right? And so do
Oh
your
yeah.
research, do your math, and pay attention to the changing trends in the industry right now, because
Yes.
if you're going to buy 7500 RPM disks,
Oh man.
you're with like consumer 4 terabyte drives, trust me, your database server is not going to be happy.
Yeah. So a lot of things obviously were said. A lot of it's interesting though. If you think about it, and let's end up with this. If you think about it, we decided to talk about storage inside SQL Server, and we talked about more or less technologies that are outside SQL Server and outside like the database world in general. It's
Yeah.
like it's yeah. Anyway. So where can people find more about you? And
Right, so
before that, please promise to send that photo.
yeah, absolutely. I
Okay,
will take
so
a screenshot now on my production system and I'll send it to you. I
perfect.
So people can reach me on Twitter. I'm at DB Argenis, so
Yes.
DBARGENIS.
Yep.
And you can also send me an email at argenis@gmail.com. I'm happy to answer questions that might come from folks there. And I have a blog at sqlblog.com, the site
Yep.
posted by Adam Mechanic and Peter DeBeta. So the full URL is www.sqlblog.com/blogs/Argenis_Fernandez.
I will
And
put both of those links, your Twitter account and your blog, on the blog post that is coming up. Do you plan to speak somewhere soon? What's
yeah,
your plans
so
for this year?
I'm actually going to SQL Bits in a few weeks.
I'll see you there. So,
Awesome. Yep.
so what else?
I will be speaking at SQL Cruise Mediterranean in June. So for those of you in Europe, we sail out of Barcelona, and we are going to be having stops in France, Italy, and Spain itself.
Yeah,
So
incredible opportunity. Yeah.
yeah, that's going to be a lot of fun, and hopefully I will get to speak in the events later on this year, like probably Dev Connections. I'm going to submit again for Dev Connections, which happens in Vegas in September. And I'm most definitely going to submit for the PASS Summit, which is right here in Seattle, where I live. I actually live in Redmond, so I'm 15 miles away from Washington. And so, yeah, hopefully I'll be at all those events. I don't think I have any SQL Saturday. Oh, wait, no, I do. I have a SQL Saturday here in Redmond, Washington, scheduled on May. I'm going to that one. And there's going to be another in Vancouver, Canada. So over on this West Coast, that will be on June 27th. So.
Okay,
Those
your
that I have in the foreseeable future, but I'm sure I'll come up with a whole bunch of more events that I'll be speaking to.
Yeah.
I love
I'm also sure that you are not going to speak only on 6 events till the end of this year, but anyway. So first people are going to be able to see you at BITS. Obviously, BITS is one of the biggest conferences in the world, so
my favorites.
Yeah, so hopefully we'll all catch up there together. So after it's 3 weeks from now? Yeah.
Something like that. I'm waiting for my superhero costume to arrive. I just ordered it.
I haven't ordered anything till now, so we'll see what's going to happen there. It will be fun. It will be fun, that's for sure. Okay, Argenis, so thank you very much for being here. Thank you very much for finally making this happen. I'll put all of the links on the blog post, and see you at BITS, man.
Take care, buddy. Good to talk to you.
Take care. Bye.
Bye.